Good day to you. This is Galactic bringing you another presentation in cutting edge science. I don't like to say cutting edge, the Fermi edge. It's a good word, Fermi, Enrico Fermi. A bow shock edge of our very own heliosphere was named after Enrico Fermi. The Fermi edge, the leading edge of our bubble, which constitutes our solar system at the edge of the heliosphere, it has a bow shock edge called the Fermi edge. And this is much better than saying the cutting edge. And we're going to find that out from Roger Boscovich and all the top-notch minds who were attempted to conquer, get as far up Everest as they could to figure out, what does the universe mean? What does it mean? And Boscovich insists with me, and all of us agree at this cutting edge, that it's not a cutting edge. It doesn't cut. If you want to get cut, go for religion, because faith is a two-edged sword. So we're not going there, we're going the other way. We don't want to get cut. And at the cutting edge is where men, sometimes physically, a few billion people have been killed that way, billions. Well, in science, what we do is we tear each other to shreds in order to climb over the bodies to stand on the shoulders of giants. Why? So we can see farther and the children will be able to follow our example? Not at all. It's to make money and to try to survive, and science is simply a version of coal mining. It's a version of politics. It's human, in other words. Well, actually, what Albert Einstein said about that is science is the greatest thing you can possibly do if you do not have to make a living at it. And I've come across rather strongly, right in my very first lecture on June 2nd, the very first words out of my mouth were, there are two kinds of science. There are two kinds of scientists. One of them is not good, comparatively, but you actually need both. And as a scientist, you must never forget that. You've got to stay humble. No matter what you discover, no matter how many men you climb on their shoulders and shove them down with your boots to get higher than they, so you can have the money and they won't have it. You're going to get the honor and the prestige, which means money, which means a bigger house, perhaps more children. You'll be able to afford it because you're a big, fat physicist. Now that's perfectly valid in the human equation. Not here it's not, and not with Albert Einstein it's not. He was a patent clerk. Humans do science, not scientists. So why does every single man Joe, certainly in America, think that a scientist is someone who makes money? There's a really, really vicious answer to that which I could cite. But since I am an American and I don't believe in pointless name calling, it's just the way humans are. You have to come out of your lab. Now, what we're doing today is not cutting edge science. It's not standing on the shoulders of giants so as to crush their shoulders. We're taking steps on the database that's been amassed by very careful, logical men to get knowledge. We're capitalizing on the knowledge that has been acquired by hook or crook. Galileo Galilei was like Barnum or Bailey or whoever does circus acts. He went straight to the Navy to sell his telescope to the Navy so the Italian Navy could bomb people at sea. That's your Galileo. As for Newton, that man was a criminal, probably out of his mind. I don't think he had syphilis because he He didn't consort with women at all. Damn, did it show. He accused Gottfried Wilhelm Leibniz of stealing his calculus. Well, what? And of course, we in Western society, we've had to compete with each other, the French against the Germans, both against the English versus everybody. And then come the colonies, about 1776 or so, you have Americans, and now we're trying to make a name for ourselves. We can't. The best we can do is Ralph Waldo Emerson. But as for science, no, not until Bradley. Well, there was actually Benjamin Franklin, though. But what am I trying to say? This is not cutting-edge science. This is something much more powerful. This is bow shock edge science. And the reason I introduce our subject this way today is because of the Boscovich curve. For the last 2 lectures, we've been studying the Boscovich curve. What is that? Why am I studying that? If you're tuning in for the first time to Anagalactic, this is by far the best moment you could have chosen. I will be broadcasting all the way through February. At the solstice, currently the benchmark is to reorient, but between now and then, we're going to be solving all of physics. Everything that's considered to be a problem, a paradox, a brick wall, the Big Bang, nobody understands that. Black holes, complete mystery. Physics has gotten out of control. They're lying. They've been doing so for 50 years. The Nobel Prize is no longer worth it. It's printed on, and that was proven in 2022. We could start there, but I want to keep moving forward. I don't want to wear you out either with bracketing information, and I see it's only been 7 minutes, so I'm still within, I like to keep this under 10 minutes, but the bracketing information is important. Why are you watching this? Why am I broadcasting? What is science doing? What's worth it? What's worth it to you? What are you trying to find out? What I did was I asked science itself, what are you trying to find out? And of course, we're human, we have to relate it to our own questions. You will have to do that as well. But we do have certain things in common as rational men. That is an enormous divisor. You have to be ruthless once you glom on to this huge difference between men. Is most men are not rational. And even rational men are mostly not rational, even though they prefer to be. Because unless you turn on your rational mind and start to use it, you're 100% emotional. The only rationality that a human being ever uses is the most rudimentary kind, of whether I should turn left or right. Well, that's a rational decision, not emotional. If you flip a coin, you look at it, you know the difference between heads and tails, so you know who gets to kick off. That's about it. And adding up sums. Other than that, 99.9% of all men and of all life has nothing to do with logic. Nothing to do with logic. Not in the scientific sense. So if you are pursuing rational logic, you're extraordinarily queer. Extraordinarily queer. And we all know this, so I'm not going to rub it in, but I am the queerest of them all now, because I'm a layman. I am not a scientist in the modern sense of the word. Now there's such a thing, and I don't want to scare the kids, but I'm just going to say there's such a thing as pee envy. Human males succumb to this pee envy. I'll just say the P stands for professional. A man like me looks at the big boys and, oh God, I wish I could grow up and have a big P. Which means a big paycheck, a big palatial mansion, a big car that begins with P, that's a wonderful car, a big pee-pee, a big pool in the backyard, a big pee-pee. Because you want the women to love you so you can screw them all because you're a big fat scientist. You made it through calculus. You're obviously intending to produce more children, since you're a survivor, the natural selectionists say, well, yeah, you know, you stepped on the shoulders of all the people that you denied jobs to while you scrambled and worked your ass off. That's very important in America. Did you pay your dues? Let's see your bank account balance. Where's the PhD, Sam? P envy. I'm back. Oh no. Oh no, that nobody's ever going to listen to me. Well, you may want that. You may have P envy. Well, if you have P envy, you've come to the right guy, because I don't. I'm going to give this all to you for free. My name will never be attached to this, but I'll tell you whose name is already getting attached to my discovery is Boscovich. A man who lived 2.5 centuries ago, and that's where we begin today. I have this on the screen so you would have something to read if you don't care to hear my droning voice while I tell you what I'm up to. And just to, let's make sure we move right along here, though. Here's what I'd like you to see. That is called the Boscovich curve, although not in this Wikipedia article. It's not. This is not a Wikipedia article on Boscovich. It's a Wikipedia article on nuclear force. But now I want you to see something. Those are called Boscovich curves. Let's keep going. Here's some stuff that's been written about Boscovich's unified field theory. But here's what I want you to see. Look at that Boscovich curve there. These are Boscovich's curves. But they're getting to what I want you to see. It's right there. Now let me scroll up a little. There's that same curve from Wikipedia. What is Boscovich's curve indicating? That would be this one on top. This is the Wikipedia curve for nuclear force. And this is the Boscovich curve. You know what the Boscovich curve is for? Well, that's what we're going to cover today. Aren't you happy now? And these are a bunch of Boscovich curves. This is pure understanding right here. It's not specifically geometry. That is a curve on a graph. It's a 2D graph. It has 2 dimensions. And you can see... And now, what's happening is we're entering the graph. And what are we? What is this? This is a proton entering the graph. And what's at the other end of the graph? Way over here to the left, what is that? That is a proton. So this is the relationship between 2 protons in space. They are separated by space in femtometers. And I promise to give you a little encapsulation of what is a femtometer. It's it's 1/10 of 1/4 of a centimeter. So now you know. And what does that mean? It's very small distance. It's atomic scale distance. So a femtometer is actually the smallest unit of measurement in use for linear separation. That linear separation is the range. You'll see that the x-coordinate system at the bottom of the graph is labeled range. You can forget that geeky name. It's distance. It's linear separation, the only thing that physics, science has ever been able to measure is linear separation in space. Nothing else. Nothing curved. Despite what you may have heard about the calculus, we'll get to that. This is about the calculus and the solution to the calculus dilemma and the solution to the infinitesimal-Limit dilemma. And is space continuous or not? And is time continuous or not? The answer will have to surprise you. It will surprise you. And in fact, I'll be guiding you into the most difficult mental transition that you've ever made in your life. The ability to see the universe for the first time. To a new threshold. That was the goal. And that still is the goal here at A&E. Men like myself, Boscovich, Einstein, real men. Men looking for the truth. We're just like little tiny governments. And we don't have slaves. We don't believe in slavery. But it's obvious that we need somebody to do some work for us. And the enormous amount of time that the human mind has been working on these problems, I inherited all that wealth. All of it. You don't need a PhD to be a scientist. You need a PhD to survive. That's not pea envy, children. That's harsh reality. This is the solution to the quantum paradox. The solution to the calculus logjam. And I believe that if you're an honest person, as such as I certainly am, that you are offended by this bullshit of the Big Bang. But there's nothing, it's like we have our hands tied behind our backs. There's nothing, we don't have a better theory. Well, what do you say is the beginning of the universe? Where do we come from? Well, if you try to find that out in terms of just biology, you'll find out, as I did, it's just professional liars. They're Darwinists, even though it's been disproved. Well, has the Big Bang been disproved? No, that has not been disproved. In fact, the Big Bang, according to Wikipedia, is a legitimate theory. I agree. And the reason I agree, for that matter, so's natural selection. Because when you say that it's a theory, you're saying that you don't know. Well, you don't. If all you have is a theory, that's not how the word theory is used anymore. The Big Bang theory and the cosmological theory and even the standard model is really just a theoretical model. The word theory means fact, and you'd better believe it. It's fact, and you'd better believe it. And it gets rough, really rough. And you can lose your life. This is about money in physics. Why do you think the Hadron Colliders are funded by governments? Because governments are wonderful organizations that love truth. No, they're not. No, they're not at all. They never have been and never will be. Never, not once. That's never happened. The Hadron Colliders, we don't go there. But it is part of life. Well, so is this diagram here in Wikipedia. I want to direct your attention to this curve one more time, and then we're going to go quickly through the Boscovich curve so you know what it is. I want you to know what this is. This is the single most important diagram that I personally have ever seen because of its enormous explanatory capacity. This is the Boscovich curve. But in the article in Wikipedia, it's not, they're not lying, they're not talking about Boscovich, but as I showed you, what is the Boscovich curve? It's the relationship between two particles. And you might say, well, that's not very much information. No, it's not. It's the behavior of two particles. And everything depends on what you mean by particle, and that is the quantum paradox. What is a particle? This has to do with the law of continuity, and you may be familiar with that, but for those of you who may not be sure what the law of continuity is about, it's about whether the universe operates in discrete steps, clickety-click, like 1, 2, 3, 4, or if it just is smooth. Every human in their right mind knows that it's smooth. For time and for space, and those are two different things. time and space are quite different. But that's not enough to say they are also extraordinarily closely related. All of these things that we have to say this way are part of the quantum paradox. Because we're talking about this curve is the curve of continuity. And it's the only curve of continuity. And it's the only answer. It's the only answer to the most basic problem that's ever faced physics, which is being raged about right now, as it has been for centuries and millennia. Is the universe continuous or not? Albert Einstein said, well, you're asking at least two questions. Is space continuous? And Newton said yes. And is time continuous? Newton said yes. Boscovich came along after Newton, and he also learned the calculus from Leibniz, because both Leibniz and Newton invented a different form of calculus. It's been said that they converge on the same calculus, and that's true. But Leibniz calculus and Newton calculus are not the same calculus at all. One deals primarily with limit, and the other one deals primarily with infinitesimal, and nobody has ever figured out the relationship between those two things. You will see both of them on this curve. The infinitesimal and the limit are both depicted on the Boscovich curve. And what is that representing again? Two protons. This is the relationship between two protons. And it's not just that, but that's the basic. This is a graph of the strong force. The strong force. The most basic property of the universe. Nothing is more basic than the strong force. And then it becomes quite difficult to deal with linear algebra, because you can see this curve is nowhere straight. There's nothing straight on this curve. And yet this curve describes what happens when two particles collide. They can't. Particles cannot collide. They never do. This has enormous implications in astrophysics. It means that the black hole does not have a singularity. Let me ask you something. Does this graph look like a singularity? No, it does not. If you know anything about what the singularity is, which describes the Big Bang, is a singularity. And the supermassive black hole is nothing more and nothing less than a mathematical singularity. The diagram of space-time curvature that collapses to a singularity does not look like this curve. But only this curve is correct, and it's not a singularity. This is what is at the center of everything in the universe of tiny nature, which would be an atom, yes. Every particle, the electron, pion, mu, tau, hadron, baryon, fucon, whatever is the idion, the electron, the proton, those are real. The photon is not real, but the electron is and the proton is, and those are the only two particles. How do they interact? The electron and the proton? Well, first of all, you have to ask, what do the protons do? They do exactly what electrons never do. Well, what's an electron? It's something that lives in another universe and has nothing to do with a proton. They're completely, utterly, fantastically different systems. Whatever the electron is, you can describe what it is perfectly as whatever the proton is not. In every respect, the proton is the opposite of the electron. First of all, in the geometry of the atom, the protons occupy the center. You would immediately raise your hand, you would get an A+. Anytime you correct me, you get an A+ for the quarter. I'm not an accredited teacher, though, so that's just a parable. But if you say, what about the neutron? Oh my God, the professor, his face is red, he's crying. I forgot again, it was a neutron. You're right, you got me. Proton and neutron. What's the difference? Nothing. They're exactly the same thing. And don't believe this shit about the electrical charge. Of course it's true. But here you have to say everything twice. It's true and it's not. This is superposition logic now. It's not double talk. And you're going to have to get used to it or you're never going to understand the universe. I'm going to teach you how to master superpositional logic. And I'll just give you a teaser until we're going to have a whole lecture on it. But it applies across the board now. It's binary logic, such as we're familiar with in science, which means yes or no. It's machine logic. Yes, it's 0, 1. But superpositional logic is that it's still the same thing, 0, 1. So what's different? Binary logic, true-false logic, propositional logic, everything we use to make rational logical science is 0, 1 because it's yes, no, because that translates to true, false, and now you can use the scientific method for a 0, 1 feedback from your experiment to get data. It has to reduce to 0, 1 so you can translate it to true, false to know if your proposition was right in your hypothesis. So it's 0, 1, that's the basis of rational logic. What's superpositional logic? It's 0, 1 with a Hadamard gate that's invisible. And that's one of the most baffling concepts. It's the basis of Hadamard gate logic. It's the basis of a certain form of the most basic geometry in the universe called the Bloch sphere, which basically describes half-spin, which is fundamental in the understanding of subatomic particle physics, is half-spin. We're going to get to that. We have the solution. We can explain the Dirac spin completely, geometrically. And of course, geometrically, that means numerically. So all these equations are going to be rewritten because of Boscovich's discovery. Except Boscovich's discovery does not unlock the floodgates anywhere. What Boscovich did was he showed that you're going to need this curve. And I'm going to show you what it means, but I made a discovery that's way ahead of this, and I did not know about the Boscovich curve. And now the work that I did last year to discover spherical geometry and the number system for it, and this thing that Boscovich discovered 2.5 centuries ago, that modern physicists are starting to look at this like, holy shit, he got all this before Bohr. He got this before Rutherford. He got it before Einstein. He described the electron orbital shell system. He did a fuck of a lot more than that. He solved the calculus, but he didn't. I did. But I found out that he did too in a different way. And it goes much deeper. This solves all the secrets. My original byline in producing my 250 lectures in 2022 was to give you the cutting edge secrets of the universe that have been discovered in science in the last century. That's all I was, and giving tours of the universe. Well, first of all, it's not the cutting edge, it's the Fermi balloon edge. Because it's not cutting, it's a curve. Do you understand? But no, I want to show you something real quick. We're going to solve everything in physics. And if you think I'm kidding, I wouldn't blame you. So here's a name I'd like you to know. Professor Dragoslav Stojkovic. He has the Boscovich unified field theory and atomism. This is just a teaser. This is the link. I'll have links in the description. He's from Serbia. Same place as Nikola Tesla. Oh, yeah. And here is another, look at that. I put in a red line to point, this is part of the Boscovich curve. That's the Boscovich curve curving in. The reason I'm pointing to the center, that is, by the way, the nucleus of an atom. So the wavy line, the Boscovich curve, is explaining the orbital shells. And up here you'll see a few other teasers of some other shit that this curve explains. I'm telling you, it's just the tip of an iceberg. This is Stolkovich talking to me. He said this to me. Various people, such as Scott Allen Miller in Chico, California, I, the Professor Stolkovich, am now encouraging Scott, who's known as Sam and who makes videos, to connect his work to Boscovich. Well, Professor, I'm so far ahead of you, it's not even funny. Alrighty, here is what I want you to see. This is the Boscovich curve. He has he has dozens, which explain everything in mechanics on a principle of force balance. This is the Wikipedia diagram for nuclear force. It's called the strong force, but there are two forms of the strong force. Very few people will tell you that, but I checked it out and it's in all the literature, including Wikipedia. There's the strong force, which this represents and this represents. That's between two protons, which you should raise your hand. What about the neutron? Shut up. It's the relationship between two protons. But there is a residual strong force that has to do with the relationship of the protons to the first orbital shell. Just the first orbital shell. Not the second, third, or fourth, or fifth, or sixth. Just the first one. And that's what this graph is for. Just two particles. The simplex form of the hydrogen atom is well known to Bohr in everyone's sense. The relationship of one proton to one electron. That's not what this is. Although it can be. It's not the electron-proton. That's that curvy line that keeps curving. That's the atom. That's the Boscovich curve for the atom. This is not the Boscovich curve for the atom. It's the curve of the strong force that binds protons together, even though they have the same electric charge, which should cause them to repel. Only Boscovich can explain that conundrum. This solves everything in top-level physics. Everything. And we're now going to be able to rewrite the Schrödinger wave equations in both forms. And the Dirac equation. But the best part of all, we're going to be able to rewrite the Einstein field equation to translate it back out of hyperbolic space. It cannot remain hyperbolic. Everyone knows that. Space is not hyperbolic. It's spherical. I discovered that. I discovered that in 2022. So what we're going to be talking about in the next lecture is the massive significance of the Boscovich curve for physics. It's skyrocketing now. You're going to see an explosion, but maybe not. It's hard to tell because this will be violently suppressed. This will entail a huge war, and it's just beginning now. And why would this be so vitally resisted? It's not linear algebra. And the Godfather makes all of his trillions and quadrillions of dollars from linear algebra. And that's why you don't understand the goddamn thing, and you never will, until you listen to me. I'm the only man that knows this right now, because I'm the only one that knows spherical geometry and how it applies to the Boscovich curve. So if you just started tuning in, God bless you, you're on the right track. That's 40 minutes. I'm trying to keep my voice down and I'm trying to stay on track, but you can see this has exploded on me yet again. I made a whole series of discoveries last year that just about killed me with excitement and intensity. Because to be at the forefront of science is really something else. And I am not a trained scientist, except as a programmer. So this is enough to kill a man like me. It's too much. But now it's going off the scales. This is going to change science. It's going to change it completely. This is what men have been praying for. Rational, righteous men have been praying for this for 70 to 100 years. Albert Einstein was the last. But Albert Einstein is back. You're looking at him. Stay tuned and don't worry about the pompous, pretentious, precocious attitude. You're going to have to overlook that. I am not up for this. I am not the man for this job. This will kill me. And so time is running out for you. But I am going to continue to make these broadcasts until you understand this. And then I'll die in the process. Sometime during the summer, I believe I'm going to die. I'm 68 years old. This is going to kill me. I am the happiest man in the world right now. I've got it. I beat these bastards to the punch. I know the Big Bang. I know the quantum paradoxes. I have the calculus. I know the universe inside and out. And I can look anyone in the eye and prove that I know and that they don't. But I leave that to Dr. Sabine Hossenfelder. Dr. Sabine is a permanent member of A&E now, as is Albert Einstein and Roger Boscovich. There's only a handful that I allow in the command module with me, buddy. Yeah. You're going to have to get used to it. I will not be having this pompous, pretentious, precocious attitude. I have to get it out of my system. Because this is overwhelming to actually get the secrets of the universe. You realize men have wanted this for thousands of years? This is the end of science. I'm the man who's leading the entire Earth to victory. It's and the megalomania. I didn't mention that. That's 40 minutes. Stay tuned. We'll be back with more on the Boscovich curve and spherical geometry, which I discovered, which explains the Boscovich curve so that a child can understand it and will understand the night sky for the first time in human history. We'll be right back.